Okay, thanks. My name is Karsten Schnitter. I'm from SAP, and I'm trying to explain something about enhancing application observability with OpenSearch and OpenTelemetry. So I'm speaking here in different roles. So I'm a software architect with SAP, and I will explain what we do there in a minute. I'm also maintainer of the Data Prepper project here in OpenSearch, and I also became a member of the technical steering committee. So like I'm wearing very different hats here. So let's have a look. What do we do with SAP and OpenSearch? So we have one service that my team maintains that is called SAP Cloud Logging. And that is built on our experience on previous services which are still running that were VM-based. But SAP Cloud Logging is a Kubernetes-based service that is hosting OpenSearch instances. So we kicked this off in 2018, so it's quite old already. And this is where the initial proposal and the first commit were made to the project. And our first production workloads came into being in 2021, so 3 years after, 2.5 to be really there. Of course, it was running earlier, but this is really when we went into production. And nowadays, you can buy instances since end of 23. And this service now has one challenge. We still need to migrate to OpenSearch 2.x. That is 2.x, not 3.x. And the reason is it's a Kubernetes-based service, and it runs at roughly 11,000 instances nowadays. And we want to do the upgrade in zero downtime, or as zero downtime as we can get. And this required us to rewrite our Kubernetes operator for that. And that took basically the entirety of last year. But we hope that in this quarter, we finally get to OpenSearch 2.x and are in a shape that we later on can then also go to OpenSearch 3.x much more easily. So that's the one part of this presentation. The other part is concerned with OpenTelemetry. So let's have a look at what does OpenTelemetry do for SAP. And we introduced a working group on observability SAP-wide in 2021, which I joined. And basically, we published guidelines to build any new observability within SAP based on OpenTelemetry 1 year after that. And starting then, we executed on this strategy. What does execution mean? Well, we were using Data Prepper, so we contributed the metrics and the logs to Data Prepper so that we can act on our strategy. We can take OpenTelemetry data and push it into OpenSearch. And that was very beneficial because now we have started to integrate OpenTelemetry in SAP runtimes. That means for developers that build on top of SAP solutions their own extensions. There are certain runtimes. One is Cloud Foundry, one is Schema, which is a Kubernetes-based runtimes. They now are integrated and emit data in OpenTelemetry to some extent, one more or less. And we are working on increasing this. And this means out of these 11,000 instances, now over 1,000 already run using OpenTelemetry. So this is the basis where I stand on what I want to present on how did we achieve it and how can you leverage the same. Okay, we do it in the following way. First, we define our target picture. And then we have a look at the OpenTelemetry ingest pipeline and the collector and the data prepper. And finally, okay, we know now how to push the data to OpenSearch, but how do we organize it in OpenSearch? That is then the final part, like what kind of mapping templates do we use and what kind of index patterns. Okay, start with defining the target picture. Good. In OpenTelemetry, we have basically 4 signals available. There's logs that are timestamps, events that have a severity, usually a log message, but can be something different. There are metrics, that is time series data, like gauges, sums, sync counters, histograms, and summaries. And there's traces. That means it's distributed traces of requests and actions. And there's a 4th signal forecoming, and this is profiles. Profiles means that is code level based insights, something you might know from Java Flight Recorder, pprof, these kind of stuff. That is at the moment in the, I think, final steps of standardization, and that will be upcoming. So we know what we might be doing in the future then as well. And what is our target picture? Our target picture here that we want to pursue is the ability to build dashboards like this one. So it looks a little bit confusing. Let's go a little bit through the details. In the middle, there are some visualizations on logs. Basically, it tells us logs that might have an error level, and here the pie chart is just indicating different services that might have an error. So we basically see what applications are unhealthy because of the logs. On the top, we see metrics. One diagram is about CPU usage, the other is about memory utilization. Again, we can see, okay, which applications are consuming a lot of memory, a lot of CPU. Finally, down here is traces. And here we have like failed traces. That means OpenTelemetry has a trace status. We can see spans that failed, and we have the duration on the right-hand side. This is all basically exemplary, just to showcase, okay, we could create something like this to investigate if our applications are running fine or if they're not. But there's one thing more that we have on the top left corner, and that is, we somehow want to select which applications we are looking at. So these are kind of selectors. This is a Kubernetes-based deployment, so we have like a namespace we can select. We can select port names. So overall, this is what we want to establish, is the ability to create such a dashboard that is built on different signals that gives us insights into the health of our applications. So to be quite placative here, we want to have our pillars of observability, logs, metrics, traces, founded on OpenSearch and held together by the common attributes that makes it possible to select the workload that we want to investigate. Okay, how do we achieve this? So there's a data flow to it. We start with the applications that we are currently having. So there are some services, some microservices, some applications, some bigger ones, some smaller ones, and probably there's existing observability. The first thing that we do, and that was also presented here this morning, is the instrumentation with OpenTelemetry. So either the applications directly, we can tap into the existing observability, we can inject some kind of OpenTelemetry into them. And for us, it's important, like, okay, we say there's an OpenTelemetry gateway that takes in all the instrumented data and then forwards it on. And where do we forward it to? Well, here in this context, we forward it to Data Prepper. And from Data Prepper, we continue to OpenSearch. And I will show how all of this works. So let's start on the instrumentation side. This is just a recap of this morning. So for OpenTelemetry, there are a lot of SDKs and agents that are available for many languages. There's auto instrumentation. You can use the APIs for manual instrumentations. For instance, you can register certain counters and the likes, and their integration into many frameworks. So if you're a Java developer, it would integrate into your logging framework. You just enable it. It will pull the logs according to your current logging configuration. You will get them in OpenTelemetry. And then there's the OpenTelemetry collector that in my previous picture was used as a gateway. So, but it can do more. It has receivers, what it's called in the collector language. These are components for integrating with existing technologies. That means they collect data into the collector. Then there are processors and aggregators to transform the data, to do something to it. And there's a new thing that is called auto transformation language that makes things a little bit easier, more prescriptive. And from there on, we use exporters to different things. So the OpenTelemetry collector itself can write to OpenSearch with some exporter. But what we do is actually we use just the plain OTLP exporter and write the data to Data Prepper. So there are some, here you can find all the references if you want to read through them. And I will not go into any more details because there was a presentation on that this morning and I don't have too much time. So what we now come to is, okay, I have the OpenTelemetry collector. I will be going into a little bit of detail on how to configure the OpenTelemetry collector, especially the exporter. So we usually configure one exporter per signal. So there's one for logs, one for metrics, one for traces. I will be saying this a whole lot more this talk. For data prepper, we use OTLP gRPC. We do have OTLP HTTP support, but it's not quite nice to use, but we are working on it. So there's a pull request that will add that hopefully soon, but there's still some work to be done. We can use MTLS if we want it, and by default it uses compression, which we can also disable. So a usual configuration would look like something like that. You don't have to read through all of this. It's more like for later browsing. Yeah, so you will see this also a lot, but you can get the idea of how this works. Okay. In the collector, we need to configure so-called pipelines. That means one pipeline per signal. It usually has a receiver. It has a batch processor that increases throughput performance by batching multiple events together and then sending them on. And what is important is not to create batches that are too large for our data prepper instance to handle. So that needs to be adjusted. That's the reason why I present that here. And then, yeah, okay, we just choose a gateway configuration. That means here an OTel receiver takes it in. It's not shown even. And then we put it out. We can extend it. For instance, there are Prometheus receivers that can scrape ports if you're running a Kubernetes deployment so that the OTel collector behaves just like Prometheus. You can scrape Prometheus itself. You can do log file tailing, whatever you like. And in the end, you end up with 3 pipelines looking like this. Okay. That's all there is to it. So now we are at OpenSearch Con. Let's focus on our own tools, right? So what do we do in Data Prepper? Well, Data Prepper is pretty similar to what we did in the collector. So what was the rhyme? There are 3 pipelines, one for each signal. So the logging pipeline is usually the easiest one. So it just has a log source, and it writes into an OpenSearch thing, nothing in between. Straightforward. For metrics, it's a little bit more, just a tiny bit more. There is a processor in the middle at the moment. You don't need to know what it does. It is just there to do some of the data processing. I will explain in a minute why metrics are more difficult to use than logs are, but you just build that up and that's it. The most complex one is the one for traces. There we actually split off the pipeline because we want to have the parts of the traces dispensed in to have the data of those. And on the other hand, we also need to do it in a different way. So the raw spans are here, service map is here. So we want to create a map of the services, how they are running. And that's why this splits off. So I have here the configuration for all of that. So logs, as I said, it's easy. You can see the source, you can see the buffer, and you can see the sink. So this is something that Data Prepper does. It takes in messages and puts them into a buffer. Here I used an in-memory buffer. You have the option to use a Kafka-based buffer or a file-based buffer. And this buffer basically determines what the batch size in the collector could be. You configure a certain buffer size and adjust the batch size in the collector to match the memory that you're running Data Prepper with. If you exceed the buffer size, there is a circuit breaker that kicks in, and Data Prepper will apply back pressure. Good. Matrix is pretty similar. You will note there's a tiny difference where there is the processor called OTelemetry inside. And finally, for the traces, it's a little bit more complicated. So there's the top part, that is what is usually called an entry pipeline, where we just configure the trace source, and then there's something that is called peer forwarder. So processing traces is a stateful operation. It's an aggregation in Data Prepper. If you run multiple instances of Data Prepper for high availability, for throughput, something like this, then they need to exchange the state. And this is what the peer forwarder does. So this you need to configure always if you have more than one instance. If you don't do it, then it might happen that your ingestion path gets scrambled. Depends a little bit on your data. And then you can configure the side where there's just the raw pipeline. That means the raw spans going through. you see there's the OTIL traces processor, and that's the one that taps also into the peer forwarded state. And on the other side, there's the service map. Also looks now very basic once the peer forwarding works. Okay, so overall, this is how the configuration looks like. The data prepper team has examples in their repository for each of those pipelines. So you can have a look at those examples. And if you want to know more about data prepper, you go to Zurich 1 in roughly an hour and listen to David and Krishna talking about it some more. Good. Now we have the ingestion pipeline running, almost. We look at what's in store for OpenSearch. But before we can do that, let's step a little bit back and look at the OpenTelemetry data model. So like what's really in this protocol. And we start with logs. So the outermost shell of log messages is a collection of so-called resource logs. So this is a collection of records, and each resource logs has inside a number of scoped logs. The scoped logs, again, so this is now like a babushka doll. Yeah, it stacks, it turtles all the way down, has the actual log records. So this is a twice nested collection of log records. This is how it looks for logs. And when data prepper takes it in, it gets like a collection of resource logs actually, and it breaks it down to the actual log records that it then handles one by one. So this is basically what the source already does. For metrics, it looks completely the same. We have resource metrics, scope metrics, the metrics themselves, but inside the metrics, there are actually the data points. And the data points will be what is the smallest unit that data prepper breaks it down to, and this is probably why we have another processor. And now, just for the recap, resource spans, and the span inside. Here it does not have any other name. This is how it looks in the tracing world. Okay. Once we know how this looks like, what are the components that we then get in such a log record that data prepper creates us for indexing in OpenSearch as a document? We get resource attributes. This is a key value hash, well, where the values can again be hashes. Something like that has a name and some value. The most important one is usually the service name that should be set. That just indicates on like what the service is emitting these kind of data. Then there is instrumentation scope attributes. Support for those was actually added to data prepper 2.11, released last week. And it looks basically pretty much similar. And then there's log attributes. While the resource attributes are stable over the runtime of the application, log attributes can change with every log record written. So this is basically like some custom field, some tenant identification, whatever you want to have it. Might be the class that emitted the log, something like that. And of course, then there are log-specific properties, something like the timestamp, the severity, and the body. So this is what logs look like. And you might find this a little bit ugly. Let me emphasize something which is ugly. And there are all these @ symbols, and the attributes also start with log. So the @ symbols were introduced because it could happen, if you were to use it dotting, that in OpenSearch there will be indexing conflicts. Like if I had a service attribute and a service name attribute, they would conflict. And that's why data prepper introduced very early this kind of dedotting. This is how the current indices look like until you come to version 2.11, where we introduced a new scheme that removes all of that. So now you will get these nice dots. And also like the prefix of log attributes was removed, it's just attributes. So try that out. That's data prepper 2.11. Okay. What does the specification of OpenTelemetry actually tell us about all of this? So resource attributes, instrumentation scope attributes, and to some extent signal attributes are somewhat universal. So resource and instrumentation scope attributes are, signal attributes can be. That means there is OpenTelemetry semantic conventions on them. That means the names to be used are specified. They are segregated by namespace. So we saw the service name, that is the service namespace with the attribute name, and it has a fixed type, it is a string. And it has a semantic meaning, it is describing the name of the service that is deployed. It's not the name of the developer, but it's like some name that indicates which service it is. And some of these signal attributes can be shared. For example, there's an HTTP namespace that contains attributes on requests and responses. That for sure can be shared on logs and spans. And then there are some signal-specific properties we saw for the logs. There's a specification that clearly states which one those are, how they are called, what type they have. And especially for the metrics, okay, they have a name, and there are again semantic conventions that tell us what metric names use for what. For instance, there is a container CPU usage. That is a name, and it tells us that is the utilization of used by the application in units of CPU. So you can use 2 full CPUs for your application, for examples. Good. So the general approach now is, we need separate templates for metrics, traces, and logs because they have separate specific fields. But when we utilize component templates, we can collect common signals and attributes into these component templates. And this is what I want to show here. So, for the resource attributes, we define a default resource component template, catching all of that we did not specify more closely. That means we have a manual mapping for resource fields from the spec. We have a mapping for the resource attributes based on their JSON type. This is what we introduced with Data Prepper 2.11 in the default templates. And we can introduce for certain of these conventions specific mappings. Like we can say, okay, yeah, we want to have these, for example, the service namespace specifically mapped because we know that a service name has only a certain size, while an exception message might be longer and we want to extend the size of that one. And then we have specific component templates based on the semantic convention, one for each. And since the semantic conventions are actually encoded in YAML, there is a way to automatically generate those. You can pass in the YAML and generate the entire component template. Okay, instrumentation scope works the same, is also something that is more on the SDK side. We can do exactly the same. And then there are signal attributes. Again, like we do a manual mapping of the specific fields and a dynamic mapping based on the attribute type. And then we can do specific component templates. Okay, and finally, you have a component template here for logs, metrics, and traces. And sometimes you want to add aliases or additional code for generalized fields. So in Data Prepper and also in OpenTelemetry, we always use the service name to describe the workload. And Data Prepper already introduced this field. So this will always be there. And the other one is we usually have an timestamp field in observability because the timestamp for each OpenTelemetry signal is called different by signal type. So like a span has a start and an end time. We need to select one of those. A metric has an observed timestamp, and a log also has 2, and it's better that we generalize on 1. So with all what I said, like now is the one yellow thing that we have a closer look. This is something how it could look like. So if you open up SAP Cloud Logging, if you had an instance and looked at the index template, it might look something like this. It's not taken out of this, but you can see like where I'm going. So this would be an OTel logs template. It has some priority. If you want to override it, you just add a new template with a higher priority and you just override it. And how would you override it? Maybe you would just exchange one of the component templates. So there's one that does just index setting. Index setting is how many replicas do I want to have and such things. Then we have OTel resources component. That means this is the default. Where I said like just from the JSON type, this is the mapping. Like if it was a JSON string, I map it into a keyword. If it was a number, I map it into an integer or a double, that kind of stuff. And then I added two specific resource components, one for Kubernetes, one for Cloud Foundry. You can look up the Cloud Foundry semantic conventions on the OpenTelemetry site to see why I did that. So just as an example, this is how I would add specific resource components. Why did I add the Kubernetes one? In Kubernetes resource convention, you can have labels that were attached to Kubernetes pods. And these labels are notorious for creating like indexing conflicts because they do not follow the semantic convention where it is clear that there will never be a field name that would be a namespace in another context. But with Kubernetes labels, that can happen. So this is a place where you want to invest some of your own time in fixing maybe the index conflicts either by a processor and data prepper or by applying a more specific mapping here. So that's the reason why it is there. Then there's the default instrumentation scope component. Usually it's not necessary to have custom ones for specific use cases. Then the attributes one, and then I added two to explain a little bit more what attributes could be. One is for exceptions. Like there is an exception attribute namespace that has the exception type, the message, the stack trace, something like this. And of course, like request attributes, like if you think what a request log entails, that is a long thing that is there. And since requests also can log headers, we again are at the problem that if you have a header that is separated by dots, we might get indexing conflicts. And that's why it's a good idea to have a specific mapping here. And of course, at the bottom, it tells us, okay, there's a default logs component. So and if you want to override it, you can mix and match all these kind of component templates. This is how we do our indexing. Our indexing is built like this, a little bit different, but that is the general idea on how we do that. Okay, so what do we end up with? We have now an index structure where there are some parts are common, like the resource attributes and the instrumentation scope, maybe the timestamp, and then there are specific parts. That means now, when we go to OpenSearch dashboards and introduce index patterns, it's quite clear we can create a log index pattern, metrics index pattern, trace index pattern, so that in the end we have signal-specific visualizations that we can build on top. But on the target picture that I showed you, we would also want to have this cross-cutting index pattern on the common fields. And that allows us then to create these kind of generic visualizations or selectors. So if somebody asks me, on what kind of workloads do you have data? I can answer with that kind of index pattern. I don't need to know whether I have metrics, logs, or traces. I just need to know, okay, there's some event with a service name like that. Good. So when we have done all of that, we are back to our target picture. We can create dashboards and visualizations on top of all that data that is combined. We can create now filters on the resource attributes that apply to all three data. That means we can switch between dashboards. We can go to the discovery plugin if the filter is pinned and have a nice selection of our data. So where do we go from here? So we have seen OpenTelemetry ingestion with data prepper. For all three signals, we have our supported OTLP formats. That means gRPC and hopefully HTTP in future. We have unpacking of batched data into separate OpenSearch documents. We have now two output formats, the old OpenSearch one and the newly introduced OTL one in Data Prepper 2.11. So basically, we have been using this for quite some time. We've done the hard work, and now with the help of Krishna and David, we have provided this in Data Prepper for other people to have it much easier to use. So from here, well, there's something called OpenSearch Catalog, and that's now the nice part. With the OTL output format, we are compatible. We have not been with the OpenSearch one, but with the new one we are. That means we can now go through the OpenSearch Catalog, which is actually a collection of visualizations and dashboards based on the simple schema for OpenSearch that we now create with Data Prepper. So we can use, for example, the improved visualizations for tracing that are already present in the catalog that address long traces much better than the observability plugin in OpenSearch that we currently have. So when we started back some years, auto instrumentation would create traces with like 2 or 3 spans per service. So you end up with like, depending on the number of services, like 20 entries. Nowadays, with the application frameworks that we have within SAP, a single service emits 100 spans, and then there comes the next service, and this is really hard to watch in OpenSearch. So using this kind of technique, we can use what is in the catalog, which is much better in viewing like this kind of amount of data. So here's the shout out now. Join the community now that we can ingest the data so much more easily with the new schema and creating more observability content actually in the OpenSearch catalog, so that we can all basically get to these kind of visualizations that I presented here. Okay, thanks.
We do have time for some questions, so
with regards to the data prepper, as you see it from a user perspective, if you zoom out, many of the feature in data prepper seems very similar to the OpenTelemetry collector. Have you gotten any features from data prepper which you sort of are missing in the OTel collector, or are they sort of solving the same problem?
That's a really good question, and they are somewhat trying to solve the same problem, but they are doing it in a different way. And there are like some features in data prepper that you will not find in your auto collector that are really important for me. So data prepper has the ability for end-to-end acknowledgements and back pressure, something that is not there in the OpenTelemetry collector. I'm not saying that every tiny screw is already there and implemented, but the architecture supports that. That means if OpenSearch for some reason is slowed on the ingest or has a problem because you had an indexing conflict, that's something that we see often. You index data, and because there's a conflict, it slows down because it has to do retries. It will apply back pressure all the way through to the pipeline already now. And that is something that the auto collector is not built to do. That's the one thing. And the other thing that data prepper has, and I think is an advantage on any other of these kind of shipment tools, is how it handles its buffer. So I've said, like I presented the in-memory buffer, but data prepper is, so far as I know, the only tool that would utilize a Kafka buffer in a way where it only writes the data to the buffer, never looks at it again unless it gets problems. Like usually you would create, like with the OTel collector, you would create a Kafka exporter, and then you would receive it. So that means you always write the data and read it back in, creating a lot of network traffic, something that data prepper avoids. And this is basically 2 plus sides that I see in this tool that makes it stand out above all others. So if you want to have that, then data prepper is your choice. If you don't need it, you can go somewhere else. You might be using the auto collector, but this is just a feature-wise comparison. I'm not like comparing performance or such things, but just like, okay, these are 2 really main features that speak to us at SAP, and this is why we started with data prepper and why we keep using it.
I saw that you were using just one receiver for logs, metrics, and trace data. But if we have already an log agent, like let's say FluentBit, and we get our logs via FluentBit and traces with receiver, is it a recommended configuration?
With our service in SAP Cloud Logging, we actually take in data with data prepper, but we have a parallel setup with FluentD also running for historical reasons. So like we need to connect to some data source, especially from Cloud Foundry, which we only were able to implement in FluentD for now. So we basically write with those 2 tools. And starting like from last week or like a month ago, we also write in the same index. It takes some coordination on index rollover, how you do that. So like you need to use some white aliases and some clever strategy to do that, but that does work still. And if you're just separating by signal, just saying like, okay, I write logs with fluent bit and the other things with data prepper, that would also work. But any such setup will a little bit like water down what I'm showing here with the kind of attributes. You can work around that by creating aliases for the fields that you're really interested in, or by adopting the same naming convention, right? But this talk really is focusing on how to index the data in a way that we can connect and correlate it.
I guess it's related to the question here, but OpenSearch has the possibility to use Prometheus as a data source. So, and we are currently using Prometheus. So, what are the disadvantages to use Prometheus as a data source instead of going through the data prepper pipeline?
Okay, this is another question I get very often. So let's be totally clear. OpenSearch is not a primary storage for metrics data, because it takes a lot of bytes to store data. So what we usually see, it's like 150 bytes per data point, and that's far beyond what Prometheus or Influx would use, right? So it's not a storage for data where you have little cardinality and high frequency. This is like usually not the main use case. Where it really shines is if you have data sets with a really high cardinality. Let's say you have request metrics and they are like split by URL, like by path or something like this, where you have uncontrolled cardinality, you have also control over, like you do this every minute. This is something that you might want to store in OpenSearch because of the cardinality problem not being a problem and you're not storing too much data. And the other approach is if you generate metrics from other signals that also have this kind of property, that is also an interesting point where you want to go. Yeah? And the final thing about it, you still have to remember, is storing logs takes a lot of space. That is what we usually see. Yeah? Like this is terabytes, and if you store metrics and they are just like a few 10 or 100 gigabytes, yeah, do you want to run a Prometheus cluster on top of it, or do you say I'm just fine because I have this one anyway? That's another thing. Yeah, but other than that, yeah, if you store massive amounts of metrics, don't use this approach.
For one more, anybody? All right, let's thank Karsten, and thank you very much.